Hello, ladies and gentlemen. So today we're going to look at exponential growth and decay, the real life examples. You're going to want the guided notes I gave you today, the pen or pencil, and then a calculator also. So we talked about this earlier. Compound interest is an example of an exponential growth, and you use this model when we're not compounding yearly, which is pretty common. Usually you compound monthly, especially for savings accounts. So this is the formula. A equals P times the quantity 1 plus r over n to the nt power. So what does all those letters mean? P is the initial amount deposited. Normally you're going to be called that the principal amount that you put into the account. A lot of times a savings account, they require you to at least put, I believe, $500 in, usually for your principal. Interest rate expressed as a decimal is your R. So R is for rate. Now, highlight this, underline this, something. Expressed as a decimal. Be very, 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 very careful. So if they give you 3.5%, there are two ways to get that to be a decimal. Here's your two ways. So either you're going to move the decimal 2 to the left, or you would divide by 100. Either way, you would get 0.035. Be very, very careful. Please make sure you get that as a decimal. Otherwise, it's going to be a lot difficult for you to get these answers. N is the number of times compounded per year, and they'll tell you in the problem how many times it's going to be compounded. So semi-annually, if they say semi-annually, your N is 2. If they say quarterly, quarter, 4, makes sense, right? Monthly, there are 12 months in a year. Weekly, how many weeks in a year? 52. And a normal year, we have 365 days. So if it's daily, it would be 365 times. T is the number of years. You're going to leave it in there. And A is the balance after T years. So let's try this actually out. So I'm going to deposit $2,900, so I'm going to underline that, in an account that has 3.5% annual interest. I need to find the balance after 2 years if my interest is compounded monthly and weekly. So I'm going to try one monthly, one weekly. So I'm going to do the monthly one right here. Let's do him first. So I'm going to set up my formula. Remember, it's A equals P, 1 plus R over N times T. So P is my principal. That's the amount I deposited, $2,900. 1 plus my rate as a decimal. So 3.5%, that as a decimal, 0.035 over N, which is the number of times I'm compounding. I am compounding monthly, so that would be 12. 12 times, because N, right? N should match here, times your time. My time is 2 years. So now, you're going to work your way through this problem. How to do that? First, figure out what's the inside. So you're going to do 2,900 equals 1 plus. Now, 0.035 divided by 12, that is 0.00292. 12 times 2, okay? You're going to want to be very precise. Otherwise, you will lose dollars, actually. And I know as well as you do, if the bank would lose dollars for me, I know I would be very angry. So be very careful. Be as precise as you possibly can. So we're going to add 1. So we're going to have 2,900, 1 plus 1 decimal point. Sorry, for what I was going to add here. So 1.00292, 12 times 2, okay? Now I'm going to figure out what this is. So 1.00292 to the 24th power. That is 1.07 approximately. When I multiply that, I get $3,109.96 finally. So that's monthly. After 2 years, that's how much money I'm going to make at the end. What about weekly? So I have $2,900 yet. 1 plus 0.035, because that's still my interest rate. But my N is going to change because I'm compounding weekly now. So 52 would be my N. So I have 52 times 2 up there. Once you put that into the calculator, this can go immediately into the calculator. However, you be very careful. Make sure you use parentheses galore so you make sure that everything is being taken to the right power and dividing and all that. You should get $3,110.20 approximately. Exponential growth models. So this is how a growth model is going to look like usually. You're going to have y equals a times the quantity, 1 plus r to the t. So a is the initial amount, just kind of like our principal was before. And r is going to be the percent increase, again, expressed as a decimal. Look at that. T is time then. So 1 plus r is your growth factor. Just kind of like how b used to be a growth factor, 1 plus r is. So let's take a look at this and see how this actually works. I have a population of buffalo. There's 38 of them originally. That's how many we put in there. Our population is going to grow 1% each year. We need to first write a growth model, and then we're going to estimate how many buffalo are going to be in our park after 70 years. So, very first thing, we need to write our model. So let's figure out, we have numbers. We have 38, we have 1%, right? That's all I need. So I have y equals a 1 plus r to the t. So, y equals my initial amount. How many buffalo did I have initially? 38. So 38 buffalo. 1 plus my rate expressed as a decimal, 0.01 to the t. So this is just getting the model right. So 38, do the parentheses here, 1.01 to the t. This is my model. So that's the first part that they're asking about. Now I can plug in that 70 years for my t to figure out how many buffalo I'm going to have. Just like that. That is equal to 76 buffalo. Notice how I didn't round because I get like 0.5 or something. You can't have 0.5 of a buffalo. So I just rounded just to 76. Just truncate the decimal. Just cut them off. So that way you just know you have 76 buffalo at least. Now, what about decay? Decaying models are probably the ones you're going to see the most. Here's some, so you're going to have, it's kind of similar to the growth, but kind of a little different. We're going to go a to the 1 minus r. Notice how it's subtraction, because it's decay. Makes sense, right? To the t. A is the initial amount, so that's the amount you're going to start with. R is the percent of decrease expressed as a decimal. Can't be more telling you guys, make sure you do decimals. T is the time. 1 minus r is your decay factor, just kind of like how B was. 1 minus r is going to be depreciation. Almost every one of us have heard about it. Your car is going to drop in value as I drive it, just because I'm driving it and the years are getting older. So let's say I buy a brand new spanking new car. It's $25,000. And I want to find the value of this car is going to decrease by 23.5% each year. Very large percent. So let's first figure out what's the model going to look like. So it's going to be y equals my initial cost of this car, $25,000. 1 minus my rate as a decimal. Oops. 0.235 to the t. So let's figure out what's inside parentheses there. 25,000. What's 1 minus 0.235? 0.765, right? To the T. This is my model, so I've answered the first part of my question. Now I need to estimate the value after 4 years. So we're going to plug a 4 in for T. So I'm going to get 25,000, 0.765 to the 4th power. If you plug that in into your calculator, you will get the approximate amount of $8,562.21. Notice how fast my car dropped in value. 4 years, and I am over half of my car has depreciated the value. That is why new cars, they drop in value exceptionally fast. It's kind of amazing how fast they drop. And that's in this video. See you later, Sabers.